Thanks for the reminder. So we are going to consider this example. The object is thrown from the ground level. Now we are considering a situation where the object is being thrown from a height above the ground. Please, are we okay? Akosia, are you okay? Safua, Bushra, and everybody.
Yes.
Okay. Do I clean the board?
No, please.
Hurry up, Zuvia, hurry up.
Mr. Yeah, please, I can't see the left side of the board.
Please.
Is it the side?
Oh, please. Yes, this side. This side.
Here or here? Where we have total hashtag distance.
Yes, please.
Let me send the screen there. I hope you can see now.
Yes, please. Thank you.
Please hurry up and let's continue. So after taking all those considerations, we then come to solving problems. Then we look at vertically downward motion. One body is being falling. Okay, so when the object is projected from a height, this time we have that's the ground level.
Mr. Dia, please, I can't see the side of the board you are standing.
Don't worry, you can see. That's the ground level. An object so this is the height h. H. An object is projected. So this is Equia Watchman standing on the tower. She throws an object. See, the object is thrown from her hand. So let's take it to be at the height of the tower level. Goes on and on till it drops on the floor or the ground. So the whole flight of the body is this. This is the whole flight of the body. The body moves from here, then on and on and on till it comes to land on the floor. Okay. Now, possible questions. The possible question is that, one, you can be asked to determine the maximum distance or the greatest distance reached. That's the first consideration. Let me adjust the screen to where I'm writing so we can see clearly. So the first consideration is that determine the maximum height or the greatest height reached. Then two, Determine the greatest or let me use maximum. Maximum height reached from the ground. From the ground. And then the last one, in terms of total distance. Distance covered. Please, are we okay?
Yes.
Let's look at the first one. How do we determine the maximum height reached? By the body. How do we determine the maximum height? And what will be the expression for it? Yes. Ideas. Yes. Zubia, Yaba, is that you?
Yes, please.
Okay, go ahead.
Did the formula U squared over 2G?
U squared over 2G. Okay. So, yes, Yaba is right. When the body is thrown, okay, this from the point of throw, this is the point of throw, to the point where the final velocity is 0. V is equal to 0. So from here to this point would give us the maximum height or the greatest height reached. So we call this interval as H max or H greatest. So I will certainly be equal to U squared over 2G. Let's look at II. And that is determine the maximum height reached from the ground. From the ground. Yeah, it's views. Yeah, but let somebody else come in. Okay. Okay.
Okay.
Yes. Somebody else. Or okay, be a what man?
U squared over G.
U squared over G equal.
No, U squared over 2G plus U squared over 2G.
But that's the same as U squared over G. Equal, I won't buy it. You have to come again. A second one before Yaba comes in. A third, no, a second opinion. Akosia.
Yeah, please, can you say H max plus H?
So, give it to me well.
U squared out of 2G plus H.
Okay, so Akosia is saying that she also think that would be U squared over 2G plus H. Yaba, what do you think?
Please, I also think U squared over 2G plus the height of the tower, H.
That's exactly what it is. The question, determine the maximum height reached from the ground. So if I'm at the ground level, what is the maximum height reached by the body? So I have to add the height of the tower to H max, which is this. Okay, so maximum height reached from the ground would be equal to u squared on 2g plus the height h of the tower. Please, any question? Then the total distance covered. What's the total distance covered during the whole flight? Ideas. Hey, Yaba again. Okay, Yaba.
U squared over G plus H.
U squared over G plus H. Wow. Fantastic. That's true. Akosia, what do you also think?
I think it's U squared over G.
U squared over G. Akosia,
Okay.
Yaba, what did you say?
Because I said U squared over G plus H.
Okay. So let's all look at it carefully. We are looking at this diagram. Okay. We are looking at the total distance covered. Please, the body was not thrown from the ground. The thrower is on top of a tower with height small h. This is the h. Okay, let me even use capital H so as to distinguish it from the small h I use. Okay, so this will be, please let's change this to capital H. If we are looking at the total distance covered, the body is thrown from here, from the top of the tower. So it will move from here to this. Okay, a distance from here to here is what we are calling as H max, U squared over 2G. When it gets to the maximum height and it's returning, it will cover the same H max, another U squared over 2. So we have U squared over 2G plus another U squared over 2G. And that is from here to here, from here back to this level. But it would also have to cover the height of the tower on which the projector or the person stands. And the height is H. So plus H. But the point is that U squared over 2G plus another U squared over 2G is equal to this, U squared on G plus H, giving us the total distance covered by the body. Please, are we okay? Good. Let's solve a question and move away from the equations, that rigorous and many equations. Juviel.
Stadia,
Yeah.
please. Since U square over 2G is equal to H, can't you also make it 2H plus capital H?
Oh, yes, you are not wrong. You see, this is equal to H max. This is also H max. So Juviel is suggesting that we write it as 2 H max plus capital H. And that's also true. Please, I'm sure it's clear to us all.
Yes, please.
Good. Did I see another hand? Asumani?
So I
Okay.
wanted you to
Mhm.
so I wanted you to go over the equations because in the YouTube video I didn't see any.
We are coming to even use it, okay? We are coming to solve a question which will require us to apply the equation. So relax, we're gonna use it, okay?
Yes.
All right. I'm dictating the question. Please get ready to write. Are we ready?
Please.
A ball is projected vertically upwards. A ball is projected vertically upwards from the ground with a velocity of 20 meters per second. A ball is projected vertically upward from the ground with a velocity of 20 meters per second. A, how high will it go? A, how high will it go? B, how long will it take to reach the highest point? B, how long will it take to reach the highest point? C, when will it return to the ground? C, when will it return to the ground? And D, with what velocity will it return to the ground? With what velocity will it return to the ground? I take the question again. A ball is projected vertically upwards from the ground with a velocity of 20 meters per second. A, how high will it go? B, how long will it take to reach the highest point? C, when will it return to the ground? And D, with what velocity will it return to the ground? Take G, gravity, acceleration due to gravity, as 10 meters per second squared. This is the problem of the day. Please, I'm giving you 5 minutes to give it a try, and I'll get back to you.
Mr. Adria,
Hello. Hello, I'm listening.
please can you repeat the question? My network was bad.
A ball is projected vertically upwards from the ground with a velocity. A ball is projected vertically upwards from the ground with a velocity of 20 meters per second. A, how high will it go? B, how long will it take to reach the highest point? B, how long will it take to reach the highest point? C, when will it return to the ground? C, when will it return to the ground? And D, with what velocity will it return to the ground? With what velocity will it return to the ground? Take G to be equal to 10 meters per second squared. All right, so I'll be with you. 5 minutes. 2 minutes. Your time is up. Your time is up. Okay, let's quickly go through it. So the initial velocity is 20 meters per second. The initial velocity u is 20 meters per second. So how high will it go? How high will it go? It means we are looking for the maximum height or the greatest height the body can get to after it being thrown or projected. And H max, or the greatest height, is equal to u squared on 2g. Therefore, 20 squared on 2 by 10. We are given gravity as 10 meters per second squared. So this is 20 meters. Let me see by hands, those of you got that correct. If you got it, let me see you. Oh, okay. Okay. Nice one. Nice one. Okay. Let's move on to the next question. How long will it take to reach the maximum point? Juviel, do you have a question?
No, please.
Okay. How long will it take to reach the maximum height or the highest point? This question demands that we look for the time taken to reach the maximum height. All right, the time taken to reach the maximum height. So T max, or yes, T max, what we are calling as the maximum, the time taken to reach this maximum height is certainly equal to U over G. U over G. But before that, let me also give this explanation for the sake of those who missed out yesterday. Instead of using the standard formula, you can also use this equation of vertically upward motion. V squared is equal to U squared minus 2J. Instead of S, we are using H for height. Now, the body is being projected vertically upward. So when it gets to the maximum height, V will be 0. So 0, for 0, whether you square it or quadruple it, the value is the same. Okay, so 0 is equal to U is 20. 20 squared minus 2 times 10 by H. This is 400 by 20H. We want to make H the subject. So let's send minus 20H to the other side of the equation and becomes a positive. So 20H is equal to, let's maintain 20 squared, because 20 can easily cancel out. And we don't have to use calculator for this. Therefore, H become 20 squared is 20 by 20. So 20 meters. So this is another way of looking at the same thing, but we also apply the same concept and then derive the standard formula or the equation. Hence, instead of going through this, you can also use this straight away to get the same thing. Please, class, are we fine? Are we okay with this?
Yes.
All right. The same thing also applies to the time. Instead of using the I want to use this side of the board. So instead of using T is equal to U on G, so that U is 20, J is 10. So that way T is 2 seconds. The time taken to reach the maximum height is 2 seconds. I can also use the first equation, V is equal to U minus dt. When the body gets to the maximum height, final velocity is 0. Initial velocity is 20 minus gravity, acceleration due to gravity, 10t. So I have 10t is equal to 20. Therefore, t is 2. And don't forget, we got this equation upon this consideration, okay, of the body reaching the maximum height and all that. So the value is certainly the same. Please, any question before we move on to C? When will it return to the ground? When will it return to the ground? Okay, the body is thrown from the ground, gets to the maximum height, and then return back to the same level where it was initially thrown. So if it takes 2 seconds to get to the maximum height, it will certainly take another 2 seconds to move from the maximum height back to the ground. So in all, when will it return to the ground, class?
4 seconds.
After 4 seconds. Okay. If you are a fan of formula, then, but how do we call this special time? How do we call this special
Time of flight.
Excellent. So time of flight would be equal to 2 times t. And because t is 2, 2 by 2, you have 4 seconds. All right, the last question. With what velocity will it return to the ground? With what velocity will it return to the ground? Somebody to help me. 2 participants, okay. So I have Yaba, Akusia. Okay, Yaba.
Mr. Teacher, please, I used V is equal to U minus GT.
V is equal to U minus GT. And
So 20, V is equal to 20 minus 40. That is 10 times 4. Then V is
But-
equal to negative.
but Yaba, at the maximum, is that the question is, with what velocity will it return to the ground? So as the body is up there, the velocity up there is 0.
Yeah.
So why 20? You get my question?
Yeah.
Because once the body is at the maximum, the velocity there is 0. Akosia, what do you have to say?
I V squared is equal to U squared plus 2GS. Then the U is 0 and
But
S
U is 0. Why?
because it's returning. So the U will become the final velocity for the first one, which was given as 0.
Okay, very well. Before we answer this, please, class, this introduces us to what we call, let's look at it, introduces us to vertically downward motion. We have looked at vertically upward motion. Let's look at vertically downward motion, and you would certainly answer yourselves after this consideration. Okay, so let's hold on and finish this, and the rest will follow, right? Okay, can I clean the board?
Yes.
Can I? Okay,
Yes.
silence means yes. So vertically upward, downward motion. Vertically downward motion. Example, we are looking at an orange or a mango falling from the stalk and dropping to the ground. Vertically downward motion. Bodies, so long as bodies find themselves within the gravitational field, in the field of gravity, a body would certainly fall and accelerate. It will fall or rise and either accelerate or decelerate with a value, a constant velocity, acceleration value equal to 9.81 meter per second squared. This value is approximated to 10 meter per second squared, as we often use in our calculations involving motions under gravity, right? Now, I told you that on the surface of the earth, yes, the gravity varies, but the variation is so insignificant, so slight or little, and that is why it is approximated to 10 meter per second squared. But the point is that this value is constant or is considered to be constant at sea level meaning that the higher we go, the lesser this value of G becomes. So if we are moving away at a higher height, okay, from the surface of the earth, the value of G varies, and the variation gravity has with height is this. G is inversely proportional to 1 over h squared, even the square of the height from the surface of the earth, meaning the more h, okay, becomes, the lesser gravity also becomes. Now, if we also move, I said the value is constant at sea level, meaning if we move below, if we could go through the earth, okay, if we move below sea level, value of G also changes. So that the higher you go, the lesser the value, the lower you go, the lesser H value as well. Okay. So bodies will always accelerate or decelerate according to this. Now, when the body is going up, because the speed with which the body goes up decreases with time, we say the body decelerates. But the deceleration is due to who? This deceleration